Thank you for having me here. Just a little bit about myself before I get started. My name is Ian Rose. My background is as a geologist, but after finishing up my grad work in geology, I sort of jumped ship on that and joined the Berkeley Institute for Data Science, or BIDS. And during my time there, I've been working on projects around the Project Jupyter ecosystem, but primarily on JupyterLab, which is what I'm going to be telling you about today. So the overall motivation for Project Jupyter as a whole is to build the tools that we need for doing interactive computation with human-in-the-loop computation, which is something that traditionally hasn't been a sort of respectable field in computer science, but for science and data science, it turns out that's a really essential thing to do, to be able to write a little code, inspect the results, maybe get some rich outputs. And so one of the things, sort of the thing that really made Project Jupyter take off was in 2012, we released the IPython notebook. I wasn't on the project at that time, but you can sort of see that it has a lot of the features that you would be familiar with from the Jupyter Notebook. There are input cells, there are outputs, there's rich rendered output, and it became popular beyond, I think, really anybody's expectations. I checked last night, and as of then, there are over 3 million notebooks publicly available on GitHub, a really astonishing number. We have some indication from the folks who work at GitHub that there are a roughly similar amount of private notebooks. So this is a tool that's become extremely widely used, and I suspect there are a lot of users in the audience right now. Since that initial release, we've had a couple of really sort of high-profile, I guess you could call them victories, but for open science. So this is the central plot from the LIGO experiment, the thing that detected gravitational waves. There are a number of features in this plot that people who are familiar with the PyData ecosystem would recognize. These plots were generated in Matplotlib. That color scale that's being cut off at the bottom there is Viridis. That color scale was developed by people who used to sit next to me in the office, Stefan van der Walt and Nathaniel Smith. And then when they published this, they actually published a series of notebooks that allow you to run the exact same analysis and discover gravitational waves for yourself. And this effort won the Nobel Prize in Physics last year. And so that was very exciting to see, and to see our tools, the PyData ecosystem broadly, our tools being used for such a cool project. We're also being used in open economics. This is a blog post that Paul Romer wrote. I don't remember when, but it was relatively recently. Paul Romer, you may recognize that name. He won the pseudo Nobel Prize in economics a few weeks ago and did a bunch of foundational work in macroeconomic modeling of technological changes. And he's been a big booster of ours for a while in terms of advocating for open economics, open research, and publishing your data and code. And he thinks that Jupyter is a big part of it. Despite these successes, the classic Jupyter Notebook interface has sort of started to show its age. It started with notebooks. Those became very popular, but then people started to ask, well, these notebooks are nice, but what if I want to open other files as well? So we made a file browser view in the notebook server, and they said, oh, okay, that's really great, but there's only so far I can go with the notebook. Sooner or later, I'm going to need an escape hatch to go for shell out to bash. So we also added a terminal to the front end, so you can open up a bash terminal and run all your familiar bash commands. And then people said, well, again, notebooks are nice, but sometimes there's no substitute for a text file. So we also added a text editor. And all these things they exist in the classic notebook interface today. I don't know the answer to this, but just out of curiosity, is anybody surprised that these things are in the classic notebook interface? Yeah, they're kind of hidden. A few hands went up, not everybody, but a few. They're kind of hidden. They're not particularly popular features, I think, despite their clear usefulness. They are sort of bolted on to the interface in a not very well thought out manner that basically follows their evolution. So we wanted to address this and also to sort of revamp the Jupyter Notebook interface. The notebook was written in 2011, 2012. You may or may not be aware, but the web has changed a lot since then. It was written using the tools of 2011. So we wanted to come up with, take all the lessons that we learned in building the notebook interface and apply them towards the next step. So to that end, our goals were to build the components for interactive computing in a really flexible and integrated manner so that people can do different spins on them, they can extend them easily, they can mix and match in different ways. We also wanted to use modern JavaScript development. This project, JupyterLab, is primarily written in TypeScript, which if you haven't come across that's JavaScript with type annotations. It's, once you start working with type annotations, it's really hard to go back. It really cuts down on a whole class of errors. So in addition to plugging TypeScript, I would also really recommend looking into the Python typings module. It really smooths out a lot of development. I'm a big fan. We use NPM and Yarn. Everything is bundled together with Webpack. And then we are using, well, one of, if not the most popular web frameworks for a lot of the UI stuff. It's funny, a year or so ago, there was essentially no React in our code base, primarily because React had a kind of scary non-open source license attached to it. And then you may or may not have heard that Facebook relicensed React, and pretty much immediately people started writing stuff in React, and so now it's all over our code base. We also have really focused on having a clean model view separation between the sort of internal state of a notebook document and then what you see on the page. What that allows us to do is do neat tricks like have multiple views of the same file at the same time. It allows us to have one source of truth for the data that you see on the page. It really cleans up a lot of stuff. We work hard to make this a high-performance interface and to have a well-thought-out user experience. We've actually done some UX UI testing, which for a project that comes out of academic science, that's not particularly common. And then these last 2 points I want to dwell on a bit. We work really hard. We've worked really hard to make a strong distinction between our private and our public APIs. And the reason we want to do that is because we want everybody in the ecosystem to actually start to scratch their own itches with this. We want people to write extensions and target our APIs, and because basically the whole community can generate much more and much cooler stuff than we can as a relatively small team. And so, so we want people to use our public APIs. If they're not working for you, we want to hear about it. The old notebook interface had basically no public APIs, and people just hacked away at it, and it has become sort of an unmaintainable state of affairs. So, but here we're really writing with extensibility in mind. And to that extent, we're trying to dog food this as much as we can. So the entire application that you're about to see is a collection of JupyterLab extensions. So if you write an extension, it is on completely equal footing with all the stuff that we write. So the overall framework is everything is an extension, write your own, and it's on equal footing with ours. So this is a screenshot of it, which I'm not going to dwell on because I'm going to show you a demo in a moment. So today, we've been developing this project for about 3.5 years. We have about 170 contributors. It's got over 13,000 commits, 3,700 releases. There's a reason that that number is so absurdly large, and that's because we have 60 core components to this project. So every time we make a release, we actually make roughly 60 releases. So divide that 3,700 by 60, and you have maybe a more reasonable number of releases we've made. It's got full support for the same notebooks that you've been working on for however long you've been working on them. It's the same file format, so you can open the exact same notebook with the classic interface or with this new interface, and everything should work the same. We've got notebooks, terminals, text editors, a file browser, code consoles, a lot of the stuff that existed in the old interface, but in a sort of better integrated manner. Yeah, you can read the rest. Oh, there's an important point at the bottom there. We want people to start using this. We're out of beta. Give it a shot, kick the tires, let us know what you think. We're going to, at least in the next couple months, we're going to try to message this a lot more, but it's ready for use. Please use it. Who's using JupyterLab? There's a big old list of things that is running off the end of the page. So I won't dwell on this too much, except for the first one I'm going to dwell on a little bit because I think it's really cool. So LSST stands for the, let's see if I can remember this, the Large Synoptic Survey Telescope. It is one of, if not the biggest ground-based telescopes that's currently being built. It's going to be deployed in the Chilean Andes. And it will be, let's see, it will be surveying the whole southern sky once every 3 days, something like that. And that's going to be generating 20 terabytes of data per night. And so this is something that is, I think that qualifies as truly large data. And one of the things that this community overall has learned in recent years is that for data that big, we want the compute to come to the data rather than the other way around. We don't want to SCP around 20 terabytes of data every day. So the LSST has chosen JupyterLab as their interface for accessing this data. And they're building all sorts of really cool tooling around JupyterLab for how they're going to analyze this data. And there's a screenshot of their particular spin on JupyterLab. Okay, so now I'm going to try to do a live demo. See how well it works. Can everybody see that? Is that at an appropriate zoom level? Okay, so this is the overall interface. We've got a file browser on the left-hand side here. There's a list of running sessions, running notebooks. We have a command palette with a bunch of commands you can execute. A list of open tabs, which is not very much right now. There's this fun new extension manager. Oops. So let's get going with the notebook. So I'm going to open this this demo of the Lorentz differential equations. And if I run a few cells, I get this nice Lorentz attractor. Has anybody ever found it challenging to, if you have some interactive or complex output that you're always having to scroll up and down to the code that generates it? That can be really annoying. So one of our favorite new features is the ability to create a new view for the output. And this breaks out this output area into a separate tab. And now I have this sort of pseudo dashboard where I can do these sliders and change the parameters of the Lorentz attractor. We also have the ability to open a new view on the same file. So if I right-click on this notebook and open a new view for it, now I have this notebook open. It's the same notebook, open twice. So I can do things like change, and it's updated automatically. There's also dragging and dropping of cells. So if I drag this cell over here, now I've dragged between two, really the same notebook. So it's a little odd to have done that, but it makes more sense when you have two different notebooks open. Okay, so the notebooks you all know and love are there, but we also have lots of other things. So I'm going to open a launcher and make a new text file. I'm going to rename this to, so I'm going to make a markdown file, and we're going to say this is a tutorial for how to use Python. But because Markdown is a first-class citizen in JupyterLab, we can open a view of this in Markdown and start editing and having code snippets here. Okay, so again, one of our goals is to have the components of this as reusable as possible and as mix and matchable as possible. So one of the things that that we frequently hear from people is that they really like Jupyter kernels, but the notebook interface itself is maybe a little too heavy. They prefer to work in text files. A lot of times I prefer to work in text files. They're simpler formats. So one of the things we can do is use a text file, but I can create a console for this text file. And I'm going to make this console, it's going to be a Python 3 console. And once this console is created for this text file, I can now press Shift-Enter in this Python code block, and it will execute in the console and show me the outputs there. And so we can do other things. Now I can start actually making maybe a blog post about how to make a plot. And if that worked, I should then be able to embed that in, oh, there we go. And so I've created this plot, and now your documentation doesn't have to go out of date just because you changed something. We can generate this plot and then embed it all in the same file. Okay. So that's live editing of Markdown documents. So out of the box, we have a bunch of different file formats that we know how to read. Obviously, notebooks are in there. Plain text files are in there. We can also do things. Oh, that one's not very interesting. That's the one we just made. We also have image editors. I'm going to close some stuff. Or not image editors, but image viewers. So here's a view from Hubble. Here's an image from Hubble. We also have native support for Vega and Vega Lite documents. So here's a Vega plot. Underneath the hood, this Vega plot is just JSON. So here's another view on the exact same plot, but using a text editor. And because we still have the same live data model that underlies both these views on the file, I can say, change this from a bar plot to a circle plot. It should update. I'll change it back to a bar because it looks better. Let's see. So those are things that are built in. What else is built in? We've got a high-performance CSV viewer. Here's the iris data. One of the really cool things about this CSV viewer is that it was engineered to within an inch of its life, so it actually is extremely high performance. It can render CSVs of well, it can basically render arbitrarily large CSVs. You will run out of browser memory before it will stop being able to render it because it does lazy loading and lazy rendering. So I'm going to try to pull off a demo here. So I've got a CSV here, which is 1.2 million rows, and I'm going to try to open it in LibreOffice. The same thing will work in Calc. So just say OK, and we're going to let it sit there for a while. You can see a progress bar down there. Now I'm going to try to navigate to the same data over here, if I can remember where it is. Here it is. Which one is it? I don't want the excerpt, I want the full one. Okay, and we're live. And we can scroll. There's 1.16 million rows of data. And eventually this will finish. Maybe not. Oh, there it goes. Okay. So the data grid is neat. It's not very interactive yet. We have great plans for it, but right now it does some pretty good, some pretty good rendering. Let's see. What else is neat? We've got, here's an example of an extension. There's an extension that we have written that is not installed in the base package, but that allows you to render GeoJSON files. A lot of people are working with GeoJSON these days. It's a really nice web-friendly format for geographic data. So here is a GeoJSON that I downloaded the other day that has the rights-of-way for all the LA Metro train systems. So this is, again, if I open it with a text editor, it is just text that describes this, but when we open it with the GeoJSON viewer, it opens it in a tab with a live map. And so we can figure out where we are, which is down here. Did anybody take the Expo line over here this morning? Yay! I took the 754. What else? There are PDF viewers. We have viewers for FASTA, which is a genomics data type. There are viewers for, well, lots of things. So they're escaping me right now, but lots of user-contributed viewers at this point. Okay, I think that's most of this. Oh, here's a couple of, I'm going to go into this one because I like this one and I wrote it. This is a GitHub viewer for JupyterLab. So we can type in a username. This is going to the JupyterLab organization, and then go to maybe the JupyterLab media repository. So I'm browsing GitHub right now. This is a repository that we have to storing some of our documentation and some of our tutorial materials. So I can open up this and sort of let the documentation give a tutorial for me while I stand here. Again, this is not locally on my machine. This is pulling it from GitHub. You can see there's also Google Drive integration that you can install. There's a whole saga that I won't get into about that. Okay. So that's the overall JupyterLab interface. So maybe some of you have never seen that before. Maybe some of you have. So this is a little, something for the people who have maybe tried JupyterLab. Maybe they tried it a year ago and it was in less polished of a state and didn't like it. So this is to try to get you to give it another shot if you haven't yet. So we've got a lot more extensions in the last few months. If you were in the previous talk in this session, there was a nice example of the bokeh Dask dashboarding, and that's recently landed in JupyterLab. So we've got here's a screenshot, but we saw a live version of that earlier. There's the ability to add different themes. So here's two screenshots of the same view, but with a light theme and a dark theme. Those are the themes that we ship automatically, but users can write their own themes. We now have these workspace and tree handlers, which is a little subtle, but I think it's a really important use case. This allows us to point to files and specific activity layouts in JupyterLab via a URL. And so if you want to share something with somebody, you can construct a URL that will open all the right files, open all the right activities, and really get them off and running quickly. We now have the ability to hook up kernel completions in text files, so that if you ever feel like you're missing tab completion, now it's there. There's persistent collapsing of cells, a better designed menu system. You can now blow up and decrease the font size in notebooks and text files. And if I were more organized, I would have done that here so that certain other UI elements weren't as blown up. And there's the fun new user interface for managing third-party extensions. So I'm going to hop back to my live demo here. Here is the list of extensions that I currently have installed in this application. If I go down here, this is actually going out to the internet and searching for other extensions that we can install into the application. So one of the fun things I like to do is one of our tutorials for creating an extension is something that adds a random XKCD comic into your JupyterLab interface. And so what I like to do is check and see how many have made that extension and then published it. So we currently have, looks like about a dozen people have published XKCD extensions to NPM. So in case you ever wanted to try a dozen versions of the exact same thing, you can try that. Okay, so that's where the application stands today. There are a few neat things that we have on the horizon that are sort of more in the planning stages. But if you're interested in them, by all means come talk to me or maybe even contribute to them. One thing that I'm very excited about is the ability to interact with large remote data sets. So we saw with that CSV example that I opened, that was about a 200 megabyte CSV. That's about the largest file that you can reasonably load in a browser tab. But clearly, a lot of people here regularly work with files that are much larger than that. And we want to build in some native tooling that allows us to more easily inspect these, that allows us to get maybe some code snippets for how to load them, and just really smooth out the process of loading really large data sets. So we're looking at like HDF5 data sets and CDF data sets, which are really common in oceanography and atmospheres. We're looking at cloud-optimized geotiffs, and then there's the old workhorse of CSVs. We want to be able to load and inspect larger and larger CSVs. This is something I was trying to get working, and kind of got it working, so I'll show it. This was my project last night. So here's sort of some of my initial experimentations in loading cloud-optimized geotiffs. Each of these geotiffs are on a live map, and each of them is about a gigabyte. And because geotiffs are a well-specified format and are able to be loaded on things like S3 as static files, we can actually do some streaming of the data sets so that you can see as I'm zooming in, it's getting sharper and sharper. And so with streaming techniques like this, we can start to do some clever things with large data sets. So that's what we're looking at here is some of the flooding due to Hurricane Harvey. This one, which is failing to load, was of some of the fires that were in Santa Rosa last year. Lots of really fun and horrible natural disasters to investigate. This one's a little more fun. This is a volcanic crater near Mammoth. It's really nice out there. It's also an active volcano, so this could be a future disaster site. So I come from a background of open science and open data. So where basically everything I ever do, I push to GitHub and in open repositories. But I've been told that in certain financial or medical contexts, there is such a thing as sensitive data. So we're working on building out some of the tools for people who do have to deal with sensitive data, things like encryption and auditing and role-based accesses, so that institutions that do need to work with that will get some tools out of the box with Jupyter. And then the big kahuna, this is something that we've had a number of false starts on, is real-time collaboration. We're working on it. Hopefully within a year or so, we'll have something usable for people to actually stand up a Jupyter Hub instance and actually allow their users to collaborate in real time on documents. And to indicate real-time collaboration, I have put up 2 versions of the same screenshot. There are some more features that we're working on that I'm not going to go into in any detail, but they're here. So by all means, talk to me if you want to hear more about them. And this is definitely not just my project. This is a large effort with dozens and hundreds of people. Some of them are listed here, also some funding sources. And thanks for listening. it looks like I have plenty of time for questions. Yeah.
Are the old notebooks end of life, or are they going to be?
So this is, we have an unfortunate naming collision in that we refer to, we use the word notebook for both the file format and the application. That's, now we're trying to encourage everybody to say the notebook is the file format. Those are the exact same. We have a new interface for reading those files. The same files will work in either interface.
Okay. The old application, would that be it?
The old application will be deprecated.
Okay.
Yeah.
What's the state of Jupyter Hub?
So Jupyter,
Like shared notebooks with people, things to create their own.
yes.
I tried it.
So Jupyter Hub is complementary to this, and is there anything in particular? It's very much alive and is.
Does it actually support reliably multiple users reading?
It supports multiple users very well. What it doesn't support is multiple users editing the same file at the same time. Yeah.
How much can I think of like JupyterLab being like a library item? Like can I like control the use of it functions and other module files and stuff like that?
I mean, we're definitely, it is more of an IDE than the old notebook interface. So to that extent, yes, like it is an IDE. As for specific features, it's still a web application. It's still not as fully featured as something like VS Code might be, or any of the other desktop IDEs. But we're moving in that direction. Yeah.
So first of all, like thank you to your entire team for this work and congratulations on getting this out.
Thanks.
My question is more about scholarly publishing.
Mm-hmm.
Is there like citation support, like sort of like R Markdown or Scan.doc citation support or something?
It's not right now. There was somebody who was on our team who has since left for higher paying jobs, who was working on that. That's the type of thing that in general, so there's a couple overlapping but distinct issues with that. So Markdown has a quasi-stable citation format, but it's not clear that it's widely supported enough for us to use it. We may eventually end up biting the bullet and adding some citation support to the notebook format, but I don't think there's not really a good story there right now. Something people want though.
Yeah. What about like, you talked about collapsing code chunks?
Mm-hmm.
Can you do that in sort of the same way you do in R Markdown? Where some you need to show and some you don't, based on your audiences?
Right now, it's fairly crude. There's a collapser here, and I can click on it, and it just hides it. We may start building that out a little bit more to have things like different contexts, in different contexts it will show different things like you suggested, but right now it's not there. Yeah?
Are you integrating any kind of visual diff or merging, like NBDime?
Yeah, so NBDime has a lab extension. I haven't checked on it recently, but it should. Last time I checked, it worked. Yeah.
So Jupyter Notebook has physical NB extensions with variable inspectors and stuff. Does JupyterLab have any for that?
So part of one of the whole motivations of JupyterLab is to have so all these NB extensions that the classic notebook has. They're all using not officially supported APIs. They're sort of nightmare to maintain. One of the whole motivations here is to have a very public, official way to make extensions. So currently existing extensions will need to be ported. They're not compatible. But the idea is to have so it's kind of annoying for current extension authors. But the idea is ultimately to have a better supported extension ecosystem. Yeah.
With such a large user base using it in totally different ways,
Mm-hmm.
how are you able to narrow down this is what things you do?
It's really hard. You get people on GitHub who who can be very angry and be like, this is obviously the best workflow. I can't imagine why you would ever want to do anything different from this. And it's like, well, no, there's lots of people who have lots of different use cases. I don't think I have a good answer. It's community management and it's hard. Yeah.
really cool JSON rendering, and I've done a little bit of work there myself on the pages. Can you speak to how you address having had such large JSON to the chat? I using NumFOCUS myself, which is some problems I really run the JSON there.
So this will run into similar problems. Like for loading documents into memory, we're kind of limited by order a couple hundred megabytes. That's about the biggest you can reasonably do. Otherwise, you'll start running into troubles. And we want to build out some of the tooling around interacting with larger data sets, but it's not there yet. Yeah.
So for the use case of multiple people in a data science team or
Mm-hmm.
something, and all using JupyterLab, how often do you see the setup where like each person has their own instance of JupyterLab installed locally, and then like sharing the files via GitHub or something, versus like having a shared server?
In a real-time collaboration setting?
Yeah, and just like the typical data science, which kind of setup would you say is more common?
I think both are very common. You know, some people, it depends on the context in which people are working. Like sometimes their notebooks are not public, right? And they will be working on some internal Jupyter Hub deployment. For my work, it's all open on GitHub, so I tend to have a more GitHub-oriented workflow. Both are valid. In the back? Yeah.
Actually, following on that, if for the collaboration, check out like particular like those of the debate for like ownership, the like custom notebook or
No, the idea would be to have something that's much more akin to Google Docs, where you're editing the same file at the same time, and there's a sophisticated and very difficult to code set of algorithms that can handle conflicts when they arise, as they inevitably do when people are editing at the same time. Yeah.
Do you have any like a locking system, say someone work on this notebook
Mhm.
and another one try to open the same thing from different browser, or will say, hey, this notebook has been is still using by somebody else?
There is something that will warn you if it is changed on disk, if, for instance, somebody else is editing the same file. It's kind of crude right now, and hopefully will become a non-problem if we have real-time collaboration up and running.
Running in the server, I mean, it could end up, everybody overriding each other.
Yeah. Yep.
what's the state of like printing support?
So in JupyterLab specifically, that's something that is on our to-do list. Like, we would love to be able to say, hey, print this specific tab, and not this tab, not like the whole HTML page, but one of the panes in the interface. It's not there right now. So in order to print a notebook from JupyterLab, you'd probably want to save it as or export it to like a PDF or something, and then print that.
Does every
Yeah.
tab have to run the same kernel?
What's that?
Does every tab have to run the same kernel?
No, you can have an arbitrary number of kernels running at the same. So if I, open all these, see all these. Whoop. Does that work? Okay. See all these have a green dot. Each of those dots indicates a running kernel, and those are all separate kernels. But they can also share kernels if you like. So you can wire up two notebooks to the same kernel, which may or may not be advised, but. Okay, I think we're just about there. So thanks for listening.